if it doesn't already exist, and I say, hey, please draw me an angle, is to draw in a graph. So give me an x and a y axis, how you normally would. Remember that this is always where we start, right? 100% of the time, that's where we start. I'm going to grab a highlighter so I can make sure you can see where my angle is. So again, we start here every single time. So that's the start of my angle. All right, so if I go to here, how many degrees is it to get to here? 90, and it's positive, right? Because if I rotate this way, it's positive. But if I rotate this way, it's negative. So I need to go this way because it's positive. So now, let's say I didn't go just this far. Let's say I went this far. How far is that far? 180. Is that far enough? Far enough? No, we need to go even further. So remember, this is 270. So 235 is going to be like halfway. Am I going to get out a protractor and double check you? No, I am surely not. You also need this part to show me how you got there. Because remember, there are different ways to get there. You could have also gone that way. You also could have rotated around once and then gone there. So there are different ways to get there. So make sure like this has to be there. So you need this, this, and how you got there. Good? Okay, let's make sure we have phones and everything away and we're paying attention. Please and thank you. Okay, this one. Here we go for our start. And I'm going to rotate the other way. I'm going to rotate clockwise this time. How much? 50 degrees. So I'm shy about 40 degrees. Ooh, I regret that a little bit. That looks a little large. But we're going to go with it. So we're going this way. Good? Okay. So 1A, let's find a coterminal angle. So 235 was our original angle. What could I do to that to find a coterminal angle? Do what? We could go negative. So 235 is our positive if we went this way. So if we went the other way, it would be negative. So let's do, let's figure out what this would be, right? We have the picture of it. So this would be 360 minus 235. So that tells me this angle is 125. Do we agree? But because we went the other direction, we're going to say negative 125. So it has to be negative because you went the other way. Could we also think about doing an extra rotation and take our 235 and add 360 to it? Yeah, so if I do 235 plus 360, that gives me 595 degrees total. And that one would be positive, because again, that would be me going around once and then going to the location. So 595, again, would be if you went around once and went to the location. 125 would be going the other direction. That's why we make it negative. So either of these would be good. If it asks for 2, then I would need both of them. So make sure you read your question carefully and see what it's asking you to do. Good? And remember, sometimes specifically they say give a negative and a positive. So I'd be prepared for that. All right, number 3. We want to draw an angle in standard position that contains the point 6,8. So basically 6,8 is our terminal. So here's my x, here's my y. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So that means my point is here. In standard position, remember that's going to mean it comes down to the center. And there's my triangle. Now, we need to know all the sides in order to find our 6 trig values. How long is this side? 6. How long is this side? How long is this side? We don't know yet. Well, you might know because you were supposed to do the problem. But let's pretend we don't know yet. So we are going to use a squared plus b squared equals c squared. And this has to be my hypotenuse. Okay? It has to. All right. So A squared plus B squared, it doesn't matter which is which, equals my C squared. C squared is what I don't know because I'm missing my hypotenuse. How do I know it's my hypotenuse? Here's my right angle and it's across from it. Again, the thing across from your right angle is your hypotenuse. Alright, so 8 squared is 64 plus 6 squared is 36. So I get 100 equals C squared. So what is C? 10. Alright, now we want to find all 6 of the trig values. Whenever you have a problem like this, your theta is always the central angle. So you can put your theta right in there. So that means this is my hypotenuse. This side is my opposite side. And this side is my adjacent side. And I think it's helpful to label those because then when you go to find your trig values, you don't have an accident there with like putting the wrong thing in. Alright, so we need to remember that sine is reciprocal buddies with who? Cosecant. If you don't remember that, that's a memorization piece before tomorrow. The next one, what do I usually put next? Sine, then cosine. And its reciprocal buddy is secant. And then tangent, and who is tangent's reciprocal buddy? Cotangent. Remember, when you're doing these, we want to make sure that we reduce our fractions and also that we don't have any roots in the denominator. But am I going to have an issue with roots here? So that's good news at least, right? That takes one issue off the table. Alright, sine is opposite over hypotenuse. My opposite is 8. My hypotenuse is 10. Should I leave my answer like that? Should I? No, because it's not reduced. What is it reduced to? 4/5. So then that means my cosecant is what? 5/4. So reduce it first and then flip. Alright, what's my cosine? What over what? You can give me the final answer. 3/5 once you reduce, which means my secant, 5/3. Tangent is TOA, opposite over adjacent. 8 over 6. What's 8 over 6 going to reduce to? What? 4/3. Remember, I actually prefer this as an improper fraction, so leave it like that. Don't switch me over to a mixed number. Don't give me decimals. We don't want either of those things. What's my cotangent going to be then? 3/4. Okay. Now, do you see how this problem is going to end up being a lot of points because of all the things you had to do? This is like 3 problems in one, yeah? So if you don't know how to do a problem like this, you've got to make sure you ask me, okay? 140 into radians. What should I multiply by? Pi over 180. So when you're going into radians, the pi goes on top. So 140 pi over 180. Can I leave my answer like that? No. Let's hack off the zeros. And then, what can I divide into both 14 and 18? 2. So I get 7 pi over 9. Again, no decimals. And I prefer improper fractions if that's where we land. We didn't here, but again, no decimals. No decimals. Alright, last one, 2 pi over 3. Converting again. 180 goes on the top this time. Pi goes in the bottom. And that's nice because then our pi's cancel. 2 times 180 is 360. And then 3 times, there's basically a 1 here. 3 times 1 is 3. What do I get when I divide? 120. Okay, so there are lots of little memorization pieces here. Again, knowing your conversion factor is a memorization piece. Knowing how to set up these 6 things is a memorization piece. If you don't already have Pythagorean theorem memorized, that'd be memorization. Knowing which way is positive and negative. right? So there's a lot of little things here to remember. Okay, let me stop.